there! In this video, we're going to be talking about file input. And by this time, you should be pretty familiar with how to get input from the user using our scan format function. If you think about it, if we needed large amounts of data, it would be really time-consuming to prompt the user for each piece and scan each piece into a variable. So instead, we have functions that allow us to interact with files. We can get large amounts of data from other locations. In order to understand what we're doing, we're going to take a more technical look at our standard print format and scan format functions. I've got their prototypes showing in the PowerPoint. Each one has a control string and a set of arguments. That control string is what we put in between the quotation marks. For a print format function, it contains any words that we want to print out and any percent codes that correspond to data that we wish to print out. Then the argument list is all of the variable names for those pieces of data that we wish to print out. Similarly, the scan format function has a control string, and it usually contains a percent code that represents some piece of data we want to read in. And its argument list contains the variable names and ampersands for where we wish to place that information. The file input and output functions work much the same way. You can see that they have the same control string and the same argument lists. The only thing that is additional is the F that precedes both functions, and it does stand for file, and the file pointer that precedes the control string in both functions. Now, a pointer is something that points to some location in memory. A file pointer points to a location in a file, and we'll deal with variable pointers in a later chapter. Here's the general syntax for declaring a file pointer. First, we need the word file in all capital letters. Then we need an asterisk, and that asterisk represents a pointer. And then we need a variable name. Now we have some standards here. It's not required that we use these names, but it is standard. But since it's a variable, we can, of course, call it whatever we want. IFP stands for input file pointer, and OFP stands for output file pointer. So if we're getting information from a file, it's an input file, and we would use IFP. If we're sending information to a file, it's an output file, and we would use OFP. To use the file, we need to open the file and have our file pointer point to it. To open a file, we're going to use the file open, or fopen function. And what we need for that function is two pieces of information: the name of the file and the mode that we want to open it in. Now there are several different modes, but there's only two that we're going to consider for our class. R for read mode, meaning we would like to read the file, and W for write mode, meaning we'd like to write information to the file. Now the file names are up to us and often depend on the type of program that we're creating. If you're using a PC, you could put just the file name here where it says file name. But if you're using a Mac, you'll have to include the entire file path starting from the root directory. Now what this function returns is the pointer to this file. So we need to make sure that we assign our file pointer the result of this function if we want it to work. And when we get done with our file, we should close it again. And to do that, we're going to use the fclose function, or the file close function. All we need to pass to fclose is the file pointer, and it will take care of the rest. So we're going to highlight all of these pieces in an example program. The major trick to dealing with files is knowing how your file is structured. In programming, the file and the program that reads it have to be a matched set. Our program is going to read this specific file. It can only read files that are set up the exact same way. So this is the header setup for a file. We have a header number, And this number indicates how many other items are in the file. So we're going to build a program that will read these numbers, and you can see from the example title, we're going to write a program that does the summation of these numbers, that adds them all together. So there are 5 numbers that we wish to add together, and any other file that we organize the same way, one that has, say, 6 numbers, if it has a 6 here, and that's followed by 6 numbers, then we could add them all together as well. The types of files that we're going to be using are unformatted. So they're not going to be Word documents. Instead, they're going to be plain text files. So I'm going to create them in Notepad. At the moment, all I'm going to do is copy this example input file to Notepad. And when I save it, I want to make sure that I save it in the same folder or directory as the program that we're going to build. So I'm going to go to the folder that we built for Intro to C programs. I'm going to store it there. I'm going to store it as input.txt. So .txt is a plain format file type. And if we save files as this type, they're not going to have any background formatting that PDFs or docs do. So here's our input file. Now we're able to build a program that will read it. So we'll go over to code blocks. We're going to make sure that our program is in the same location as our file. This will be file sum.c. It's a program that calculates the sum of values from a file. So now, if we were to check within our folder, we would have both our program and our input file. Now, this is important for people who are using PCs. We need to put the program and the file in the same folder or directory. And that way we can use just the name of the file in our fopen function. So the purpose of our program is to read values from a file and add them all together. We don't need any special libraries, just our standard input-output library. So now in main, we're going to create our file pointer. Remember, file in all capital letters, asterisk for pointer, so file pointer. I'm going to call mine IFP for input file pointer. And this is because we're using the file as the input to our program. So this is an input file pointer. Then we're going to create any other variables we might need for our program. Since we're going to be reading things more than once, we're going to need a loop. And since the header number tells us how many times we're going to do that, we'll build a for loop. So we're going to need I and header, the current value, and the sum that we're calculating. Now we're ready to start assigning values to our variables. We're going to start with IFP. We want our input file pointer to point to our input file. So we're going to use the fopen function. We want to open input.txt. And since we want to get numbers from it, we want to open it in read mode. So we're going to open the file, input.txt, for reading, and we want the file pointer that is returned by this function to be stored in IFP, or input file pointer. Now we're ready to get information from the file. The first thing in the file, remember, is this number that tells us how many other items are in the file. So the first thing we're going to do is read this number. We're going to read or scan from the input file pointer an integer that we would like to store into header. Now header is equal to 5. We know that there are 5 other numbers in the file, so 5 times we're going to read again from the input file pointer the current value. And at each iteration, we want to add the current value to our sum so that we can calculate that. We're going to, for the moment, print values to the screen. We'll say the sum of the numbers in the file, or whatever sum we calculated. We'll get that from sum. And then before we finish our program, we want to close our file again. So we're going to pass our file pointer to the fclose function. Okay. So now we're ready to see if it's working right. We're going to build and run. And it says the sum of the numbers in our file are 853, which is something that we can double check with the calculator to make sure that all of these values, if we add them up, we get 853. I want to trace through what's happening real quick so that we can make sure that we understand. File *ifp creates a file pointer. The fopen function opens the file for read mode. When we open a file, we start our file pointer at the very beginning of the file. So if you can see the cursor here next to 5, that's the beginning of the file. That's where our file pointer starts. And every time we use the file scan format function, or fscanf, we advance the file pointer by 1 token. Tokens are separated by white space. So in this case, our white space is a new line, but we could also separate with individual spaces. And each of these would still be a separate token. And when we use fscanf here to get the header number, we're going to read the first token, which is still 5, and advance to the next part of the file. So you can see if we run it again with the file set up this way, we still get the same output. So then we have our for loop. We start I at 0 and keep I strictly less than header and increment y1 each time. This will give us 5 iterations, an iteration for each value of I that is strictly less than 5. So I equal to 0, I equal to 1, I equal to 2, I equal to 3, and I equal to 4. In each iteration, we're going to use the fscanf function, the file scan format function, to read from the input file, which will read from the location of the cursor the next token. So we're going to read this value 150 into current value. And current value then gets added on to sum. So remember, this shorthand is the same as saying sum is equal to sum plus current value. So when we add these together, we're going to be doing sum is equal to 0 plus the current value, which is 150. Okay. That'll end our for loop, so we'll go back to the top, and as long as I is less than 5, we're going to iterate again. So we're going to read our next token into current value. So this will replace the value of current value with 136. And we're going to add that to sum. On our next iteration, when we use the file scan format function, we'll read the next token. So each time we read from the file, we advance the file pointer. We can't go backwards or back to the beginning without closing and reopening the file. So after all 5 iterations, we'll have sum equal to the sum of all the values in the file, and we're able to print that out for the user. Now it's your turn to practice. Write a short program that reads numbers from a file and determines if each integer is even or odd. An example input is shown below. And the first number indicates how many numbers are to be tested. So this is the same organization, the same header type of file, where the first number is the header number and tells us how many other numbers there are to process. Then for each number, we should print that number is even or that number is odd. Pause the video and try the practice program on your own. Then start it again and I'll show you my solution. Okay, if we're building a program to read numbers from a file, there's some things that we're going to need to build in. Just like our previous program, we're probably going to need the header value, something to store how many times we'd like to do something, and the current number so that we can keep track of which value we're currently processing. Like all other variables, we can do a declaration and an initialization in the same step. So we can also declare a file pointer and initialize it to some file in the same step. So we're going to declare the file pointer file *ifp and initialize it to the file that we open with our fopen function by providing the name and the mode. And we want to open it in read mode. Same as before, we're going to read the header number in first. And that will tell us how many times we need to do something. For each iteration, we need to read in the number from the file. We're going to store as current number. Then we need to check to see if the number is even or odd. If a number is evenly divisible by 2, meaning there's no remainder after being divided by 2, then that number is even. And if not, then it must be odd. And then we'll go on to our next number. So we'll move on to the next iteration. After we've processed all the numbers, we're ready to close the file again. So we'll pass our file pointer to the fclose function, and we're ready to test. Now I haven't changed the input file. It's the same one that we were looking at last time. But our program should work because it has the same organization. The first number tells us how many numbers there are to process. So since the header number is 5, it should process 5 numbers. And for each number in the file, it's going to tell us whether that number is even or odd. So all of the even numbers come up even. The only odd number comes up odd. So our file is working correctly. Now the other common file organization is called Sentinel. So So this one's header. There's a header number at the top. In a Sentinel organization, there's some value at the bottom that indicates we've run out of values. So let's take a look at how we would process a file of this type. We have integers and we want to keep reading until we reach the 0 at the end, and we don't want to read in 0. We're going to modify this file to read in the other file type. And instead of reading a header number, the header no longer exists, we're going to read until we get to the end file marker, which in this case is 0. So we're going to read in a number from the input file pointer and store that as our current number. And as long as that number is not the Sentinel value, which we've defined as 0, as long as that number is not 0, then we can process it and read in the next number. So as long as we've not reached the end of the file, we can keep reading. And our output looks the same either way. The user is not going to be interested in how the input file is organized unless they have to create it themselves. So the output, everything that the user sees, is the same either way. You may want to do some other practice programs on your own to make sure you get really comfortable with the different types of files and how to read them in. In our next video, we'll take a look at how we can put information in a file using output file functions. We'll see you then.